And now we're online. Thank you. That's good. All right. Claire did a great job of reading a little narrative in there. There's some other timelines about me here, but what I really wanted to take this slide to do is talk to you about, the talk is Rumble in the Jungle. And the story is about a failure that happened not that long ago, say only in the last 10, 12 years, when the repercussions of the failure, when it was realized, and the story of the aftermath, which is part of my presentation. The story actually goes back closer to almost 20 years. In fact, almost 30 years when you add it all up, almost the duration of my time up here on the calendar, on my slide. My role in the project, my perspective is that of an engaged witness. Okay, I was not involved in the project at the time. And in fact, when we talk a bit more in the next coming slides about the elapsed time between engineers' involvement and then their successor engineers that were involved, not just individuals, but companies, a lot of time in a consulting profession, 10 years, 15 years, 20 years can be a career in many. So there was, in this story, SRK Consulting was one of several named firms. And we also had a few named individuals among, as did the other firms. And my job was in that consulting lifetime or that duration, some of those folks have moved on to other positions. So I became the corporate representative for the company. I worked with our defendants. I think one of the good things to know in professional services here that, as you hear a bit more on, that litigation in this case named the consulting firms, and they also named individuals. No one wants their name as an individual, somebody versus you as the defendant. So what happened, I have to say across the board, is all companies stood next to their named individuals, whether they were part of the firm or not. I mean, that's just the way the business works, right? So my job was to liaise with my friends and colleagues that I'd worked with for years, to help them stay on board, to help them be advised, to be ready when we needed them in this aftermath event. I was the one who gave 2 depositions. I don't really recommend that if you can avoid them, but if you have an opportunity to practice or to read a transcript of someone who has been, whether it's a professional geologist, professional engineer, whatever professional service specialty you have, that type of inquiry about how you approached, who you are, what your skills are, and how you solve this problem, that experience gives you great insight into how you approach your business and where you go. It doesn't make you scared. It's just this good discipline about why we do reviews, why we have the record keeping we do, and why we go through the best practice in engineering design and geology. This whole process, in addition to the depositions and working with our individual named defendants, my job was to liaise with our legal counsel, both internal and external. And it was my job to sort of be the clearinghouse for the massive amounts of reports, documentation of communications, faxes. Can you believe that? Yeah, lots of faxes. Lots of hard copy information, which is probably in a way interesting in that since the project went so far back, we had a large hard copy record. Today, almost everything is digital and PDF and organized. We'll talk a bit more about records retention as the lessons learned here. This whole process of my engaged witness status lasted about 8 years, and it was a meaningful amount of my time when I wasn't working with clients or doing other things for the company. Today, there's actually some pretty fascinating details about the geotechnical conditions, the geology, the summary of how the progressive site investigations were advanced and how they were used to build interpretations of what could be built and how it should be built. But I'm not going to spend a lot of time on that. A lot of that isn't my business to share, frankly. But I can give you the big picture of what things look like, the essentials of this mine. So 97. Wasn't the first time the project had been examined, but it was the start of this timeline that matters. So between 1997 and 2003, this was a greenfield project in Latin America, and it was starting in the pre-feasibility phase all the way up to detailed engineering in that timeline. Construction of the project did start in 2003, and it took about a year of pit development up there in the top right, pre-stripping. And pre-stripping resulted in waste rock, construction of the waste rock or country rock pile there in the top left, and also construction of the gold heap leach facility, which is the lower left-hand side of those of the 3 images up there. This mine was going to be an 8-year, had a mine life of 8 years. It was going to produce on the order of 60,000 ounces of gold a year. almost 500,000 overall. And by the way, the economics of the gold, the feasibility study in 2000 had gold maybe at $365 an ounce, and they were making good money at that rate with the costs we had at the time. To access that amount, to produce that amount of gold, they had to move about 15 million metric tons of waste rock and about 11 million tons of leach ore. Now, before I go any farther, I do want to talk about the technical team, not just my firm and the individuals I've talked about already, but the other firms that were involved. All of these firms are top-notch. And the team, and to this day, are doing good work, good engineering, successful, safe projects, and delivering safe projects that meet or exceed investor expectations. The individual specialists, before this particular project, certainly before and well after, they've had, they're strong. I wouldn't hesitate to work with any one of them in the future here. And yet, that talent base was present on this project, and yet this project failed. So this story is about why, some of the reasons why, and then give you some ideas as to what I've carried out of this as lessons learned, which is great to share, insights to share with you. Okay, let's look a little closer at from the essentials to the sequence, what led up to the failure. So these are contour lines, these little thin dash lines, which you can see here is we're on a sort of an undulating natural slope that's one side of a valley in this country. The open pit was a side cut. Basically cut it into a hillside. You saw that early, there's actually a kind of a nice staggered view, but at the end of the day, it was sort of the resource, the overburden and the resource were going to develop probably a pit close to the water table, but not so deep below it. The haul distance for the country rock was about, 750 meters. And the leach ore that was mined was pre-treated near the pit, and then it was conveyed with an overhead conveyor system onto the heap leach pad. If you look closer at the heap leach pad there in the lower left, you see the pad itself is a prismatic shape, all under an HDP lined plastic. You also have a buttress, which was an engineered structural fill that was designed to, because of the slope and because of our knowledge of the geology, that was designed to function as actually a buttress. And then below the buttress, you had three ponds, a stormwater intermediate and a pregnant PLS pond, or pregnant solution pond. And it's just covered up on our screen here, but in the lower right-hand corner, you see it, the ADR plant, the absorption desorption recovery plant, which is the gold recovery plant, which traditionally is easy to put right next to once you've produced the PLS right behind it. Keep your eye on that spot as we go forward here. So the construction started, I said, in late 2003, and startup of the initial heap leach operation was in early 2005. Once the owner was pouring gold, he now had funding and he had success, and he authorized an upstream expansion of that, what we call the phase one heap, that gray heap you see there. This uphill heap expansion was going to fill the space in between the uphill side of the heap leach facility and the downhill toe of the waste rock dump. That expansion was going to be connected through liner and the PLS conveyance system, so everything was designed in a way that gravity drainage was still achieved for the leach solution. It flowed through the base of the phase one heap leach and then was collected in the process ponds. This uphill heap expansion took about a year to get designed and through whatever permitting authority or authorizations are required. And the construction of that uphill heap started in early 2006. So they've been producing gold throughout all of calendar year 2005 for the primary heap. They commissioned a design of that upstream or that uphill heap leach expansion, and they were just starting to prep the ground surface and start to lay plastic a year later in early 2006. The rumble. Cracks, subsidence cracks, displacement cracks started to be observed in late 2006 and the first half of 2007. That's never good. There's some amount of settlement expected, and there's some amount of movement expected as we unload and load and compact and start to surcharge the subgrade. But these cracks were something that stood out and were recorded and mapped and surveyed. So in the first half of 2007, the owner's team knew that something, and the site contractors knew that there was something to pay attention to. In May of 2007, there was enough cracking and the owner was thinking down the road to say, I need an opinion about this. I need to have a geotechnical assessment of, do I have a real problem here or not? And in May of 2007, they received an official report from another engineering firm that said, you know what, there is potential for a massive, deep-seated landslide. And the zone of this landslide is somewhere in the areas we're seeing these crackings up by the waste rock dump, and it may encroach on the heap leach facility below. That was May of 2007. So based on this finding, the owner did the right thing. Said, look, in July of 2007, they stopped adding cyanide to their circuit. They started to drain down the heap, all in a risk management strategy to say in the event of a failure that we would have reduced the cyanide levels and all the regulated constituents that we're adding that are toxic to people in the environment. We want to have those at as low a level as possible. And then 3 months after that process in July, the landslide happened. This landslide, the engineers estimated, took about 24 hours in that zone outlined in orange. And at the end of that 24-hour period, the engineering estimates were 35 million cubic meters of material had moved. 35 million, about 3 times, more than 2.5 times the waste rock dump and 3 times the heap leach facility. Now, they didn't move and disappear down the valley. It just moved. Displacements were probably in the order of a meter in some areas, as much as a meter. In some area and some scarps you'll see in the photos that follow, more substantial than that. So you had 35 million cubic yards move, and the failure plane was well below the base of the waste rock dump or the heap leach. It was at a geologic contact between what's called the Montevideo Formation and then a Tellurian Formation, a bedrock zone. And there was a weakness, a lubricated weakness in that area, and that was one of the reasons the failure happened. This is a look at an oblique photo of the mine before the failure. And I think for those in the room, you can see it reasonably well. Up here in the top right, the schematics I was showing you are basically drawn off or sketched off of topography. So there's the open pit, that side cut on the upper right-hand side of the photo. You can see the waste rock dump is basically, you can see the benching of the waste rock dump, and you can see the dump, and you can see them filling gradually up to that ridge line between the pit and the waste rock dump. You can also see the heap leach facility looking straight on, and the 3 process ponds in the ADR plant, that little white roofed building just to the right of the PLS pond. 1 or 2 other things this vantage point gives us too is to look at how close things are. I talked about the 3/4 of a kilometer distance from the center of the open pit to the waste rock dump. In fact, you can see geologically there's structures that impacted the pit slope stability and the design of the pit. But the same geology that was being studied in the open pit and interpreted for designing the safe pit slopes would have been quite relevant to some of the decisions that were being, or design information that was being used over on to the left by the waste rock dump and the heap leach facility. And what you see here in between, these are ancillary connections here. The overhead conveyor runs right along this line. You see the pre-processing area near the pit where there's some pre-agglomeration before it was placed on the pad. And then once the material got to the pad, they had a series of grasshopper conveyors that sort of distributed the heap leach ore based on the plan. And in fact, in this photo, you can see they're wetting or leaching on this top. That's the darker color. And here's where the failure basically took place. So what you saw was displacement starting up near the foot. I call it this primary failure zone. Most of the displacement, the significant displacement was on the upper bound, as you might imagine. That's where the 1 meter to 1.5 meters over a 30, 40 day, 50, 60 day period happened. Most of the prime movement and damage, the conveyor system, I'm told by one of the operators who came out, had a cigarette in the correct safe spot and took a look at the conveyor system, the overhead conveyor system, which was supposed to go straight on top of the heap. And that morning, it was pointed a different direction. They knew that something was coming. In fact, that was one of the areas where they had seen displacement in the first half of 2007. These foundations of their conveyor system were not staying where they were built. So the good news is here, if this is all bad news if you want to have a mind to operate here, but the good news is there was monitoring and proactive engagement by the owner. There was independent reviews looking at what was possible, what could go wrong, and they correctly identified a failure scenario, which ultimately did happen. Cyanide, other solutions were contained, but I tell you what, when you look at the picture of before and after, it's pretty amazing when you think about 35 million tons of material moving around And keeping your eye on, this is of course looking sort towards the west along that buttress. That's the green grassy area you see on the right-hand side. You see the toe of the heap on upper right-hand side. You see the three process ponds coming towards you from the stormwater in the back to an intermediate pond to the PLS pond, which is obscured. And that little square building there with the roof line is the ADR plant. So this was what it was supposed to look like, and this is what happened when it was over. You can see that the ADR plant is destroyed. You can see that the right hand looking uphill, the right-hand side of the heap was also compromised. We had ore material fail into the scarp. But you don't see mass movement. It didn't just keep going from the right all the way downhill to the left. So most of that buttress that you're seeing, again, that green grassy area did its job and held the heap in place. But most of the other materials in the access road, there's enough displacement that mud flows into the PLS pond and displacement of the foundation of the ADR plant, that was basically ruined and was destroyed. At the end of the day, less than 2 years into production, that 8-year mine plan was truncated immediately. That's the knockout in the rumble in the jungle. So when you think about it, I think there was roughly 75% of the mine life for the future gold production was not going to happen in any time soon. The market, of course, responds to a failure to meet investor expectations, not to mention the environmental and ecological concerns about what did happen here and how bad is it. And that not only had a monetary impact on the owner's ability to raise capital, but it created a negative perception in the investment community and the industry as a whole. Just to fast forward to today, if you were to take a look at this site today, you would see a lot more green. Many parts of Latin America, at least in Central America and Northern South America, it's not hard to grow grass and vegetation fast. But you can see here, that's the heap leach facility. It's been not so much regraded, but it has been covered and stabilized. The PLS pond on the lower right-hand side of that pond sequence is gone. The ADR plant is long gone. The ponds are still there for stormwater controls. On the uphill right-hand side, you see the waste rock dump still parked there. What is interesting is there is a redevelopment plan for this project. As late as 2019, there's a new owner that says, everything is stable over there. We're not going to use these facilities, but we've got to plan for some incremental expansions where we can actually, there's still a lot of gold left in this hillside. Like there still is a responsible development plan, even with the history we have here, that technically I think the issues have been captured, understood, and isolated, and there is an opportunity to redevelop and extend this mine. Probably not at the scale that was originally envisioned, but someone is going to make this property make a little bit of money the right way. Okay, so that's the overview of the failure itself and the aftermath, the immediate aftermath. Let's look at the project development timeline for a second, because this helps me frame sort of how things changed and maybe point to a few of the areas where why did these experts working together not achieve the right outcome? So most of you recognize the terms up here, at least the abbreviations. We're talking about a conventional front-end loaded engineering or development timeline. Starting with the preliminary feasibility study, that was the 1997 start point I shared with you. And of course, the PFS is where the mine plan and the initial reserves were stated. The PFS was an open pit and a heap leach operation. Just so happened that the heap leach and the waste rock dump were flipped in the PFS. When the feasibility study was commissioned and completed, the heap leach facility and waste rock reversed to where we saw them in the plan. The feasibility study was used to raise money and to guide the development of the detailed engineering phase, the third box in that series. Once the detailed engineering was completed, and the project was fully funded for construction started, and then we had the commissioning process and entering operations. During this timeline, let's look at the ownership changes. This isn't that unusual, I think, even in the industry today. For a major mining company might come in and buy something that's been taken to the resource or PEA level, for example. But in this case, this project, an 8-year gold mine, started off with an ownership team that developed the preliminary feasibility study. They funded the feasibility study, and they had raised the money to start the detailed engineering, but they didn't get far. Basically, there was about a 3-year hiatus when the gold price wasn't strong enough, and the investor appetite for or lending or financial, the ability to raise capital was limited. So that owner number one sold the project about 3 years later in the right middle of, engineering had been halted until owner two came in. The second owner came in, also not the same, the same credit I give to them. They've built mines successfully around the world. This owner team came in and they ran the project from detailed engineering through construction through operations. And interestingly enough, the shutdown, which we talked about in that October 2007, roughly a 2-year period after the shutdown before there was another ownership change where this owner number three bought the project and other assets that were in the portfolio of owner number two. During this whole timeline, there was continuity in terms of the mine planning and process engineering designs. One consulting firm or one consulting team from owner one to into the operations phase through owner two. It's not just external consultants. This project team had an established internal owners team with technical resources as well. That was helpful. That always helps. Same thing goes for the pit slope design consultant. Remember, the pit tucked around the corner, that same ridge line, had some interesting structural controls and some early failures during pre-stripping that raised a red flag, or at least a yellow flag, with the owner's team. And the pit slope design consultant was trying to solve what was it about this structure that was causing them problems. And in fact, it was pretty significant, I think, at the time of the project's operations, that had they not gotten the pit slope design right or mitigate the risks they were facing, the mine would have had to shut down until they had. So a lot of attention placed on the pit slope work, and at a good firm looking after those issues. And then the last piece I'm going to highlight is this heap leach consultant role. There were 3 different consulting firms involved in the timeline of designing the heap leach facility. The first one completed the preliminary feasibility study design. And most of you know that level of detail is enough, again, to spec reserves, but it's nowhere near ready to be built. So that consulting firm did field work and issued their design report and did their calculations, and then handed off to heap leach consultant number 2. That firm picked up the feasibility study level design and prepared the detailed engineering for that first phase of the heap leach pad. And we'll talk a bit about this transition in a moment here, but that second transition between the middle consultant and the last consultant happened because of a change in the ownership team. Sorry, not the ownership team, but the engineer of record role for that second design firm. So here's what's happening. You have an engineer of record responsibility for the preliminary feasibility study. That's the first consultant. Then that hands off to a second engineer of record. And right near the end of detailed engineering before construction starts, that second engineering firm tells the owner, we've had a transition. We now have a new engineer of record assigned, and the former one is no longer part of the organization. The client said, whoa, wait a second. I liked the engineer of record I had. I want to be sure you guys can do the job, and they rebid the detailed the construction quality assurance phase. This is important. I think we're going to talk about this in 1 or 2 more slides about this engineer of record role and what some of the new thinking, which I think really incorporates a lot of what we found as weaknesses in the past practices, and how that responsibility should be handled to manage these transitions more smoothly. So once that third design consultant came in, they actually reissued the drawing set for that first phase of heap leach. They had their logo on it, their stamp, and they went out and they watched it get built, and they issued the as-built report. I'm a professional engineer. I've been doing this. I don't stamp a lot of drawings, but one of the things I learned is that if I stamp a drawing, I'm taking responsibility for this product. With public safety is involved or environmental risk is involved, I'm accountable for my design work. That's what to me, that stamp and that education, that certification symbolizes that, right? What I also think is, I don't think about the design that I inherited because it's now mine. See, in this, what I want to emphasize here, the engineer of record between heap leach consultant 2 and 3 was, you changed my drawings, you own the design assumptions, and is there a transfer of to what degree was there a transfer of responsibility to that next consultant? That last engineer of record, they're the ones that are ultimately accountable for how it was built and the decisions that were made as it was built. Okay, just a quick look at the deliverables that were produced along the way, just to give you a highlight the geotechnical investigation discussion. So in the PFS phase, there was a geotechnical investigation. It was designed, it was looking at a different layout, but it was looking at a PFS level, which is, again, not for detailed engineering, but drill geotechnical borings within the footprint of the facility, reviewing the site geology, coming up, looking at borrow areas for material that you can use for whatever fills or drainage layers you want to use. You do your design. The heap leach consultant 2 did another geotechnical investigation. A few more things were on their plate, but essentially they were looking to figure out, now we've got more certainty on how the pad is going to be built, how many tons are going to be loaded, what's the amount of, what's the maximum fill placement we're going to have, height of the facility. A geotechnical investigation was conducted by consultant number 2. By the time the third consultant came in, we were already at detailed engineering was completed. There might have been verifying a few things, but they basically went into design based on these two geotech programs. And not only did they update the engineering itself, they also did the detailed engineering for that uphill expansion. Okay. So the essentials of the failure and a bit of the timeline of how the project got to the point before failure. And it did fail. So 2 years after the shutdown, say in 2009, the owner, remember the new owner that stepped in after the shutdown, the third owner, got a hold of his attorneys and filed what was called a statement of claim and named the 3 design firms and about a dozen individual licensed engineers that have been involved in the project in some form or another, whether they put a stamp on a piece of paper or they were a reviewer. And not every jurisdiction in the world allows that. Certainly the firms can be pursued legally, but in this particular jurisdiction, it wasn't just the name of the firm, but the people involved. And this statement, the core part of the statement that resonates to me that I share with you was this. The firms and the individuals named, the named individuals, quote, failed to perform within the standards that a reasonable and prudent practitioner would maintain in the same circumstances. That definition slightly varies in parts of the US, Canada, but you know what? It essentially is a global definition, and I'll talk more about a broader interpretation of that. Yes?
What failed is the base dump, and why are they trying to sue the heap leach consultants?
Kadri, I have been down so many rabbit holes thinking about that same discussion. The bottom line is that when your client hires you as a specialist, they are relying on your opinion. And your opinion is a broad definition that if you're going to build this facility there, they're assuming you're saying it's safe. And the heap leach facility was damaged. So the heap leach design firms were tagged. Whoever was looking at the geologic hazard, the fact where it started didn't matter. That we should have known. Other engineers would, and certainly the expert witnesses that came in later all had 20/20 hindsight, but that was the essence of it. Should have known. You're the expert. We're not the expert. We're the owner.
Terry, if I can expand off of Dr. Daglin's question really quick. The thing that I'm missing here even greater is the why. Why sue at all? What did they need the capital from the suit for? Or was it just an attempt to claim capital? I'm not seeing the motivation.
I'll be a little careful here, Claire, because there is a real answer to that. A consulting firm, a mining company, like the owner's team that developed and started to operate the mine, they have a market cap they're trading on. They have an asset base of a resource in the ground. And it's measured in tens of millions of dollars, right? I'll give you SRK as an example. SRK US is about 140 people. Our asset base is our intellectual capital. There's no pot of gold. We don't have you don't have a Fort Knox downtown where we just store all of our assets. Those assets are what coming out the door. So there really is no if you're talking about $100 million loss in market cap or $100 million loss in market cap plus reputation plus blah, 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 there's no way you're going to collect that from really, let alone SRK, from any professional services firm. You do see big settlements. You see insurance steps in, and some of the larger EPC firms, the Fluors, the Bechtels, the Worley Parsons, they all have a much larger insurance pool, perhaps. So it is about the insurance pool. But even with that, Claire, I don't. Most professional services firms that say do $60 to $100 million a year of work, of fee revenue, probably carried $10 million. So there's nowhere near the offset of what was lost in this project. So it kind of felt like, I'm not sure, you have to draw your own conclusions about that, but there is no pot of gold in any of these design professional firms if you suffer a loss like this.
So it's essentially more about a legal record of placing blame elsewhere.
Yeah, you could say that. I'd also point you to that the last owner bought it after the failure. So clearly they didn't lose value
No.
because the asset was already impaired. So really their play was, what does it cost me to pursue this litigation versus what I might get back? So really the loss was that intermediate owner, owner number 2, that sold at a significant impairment. And
Thank you.
okay. All right, so 2 years later, named individuals, this was the alleged failure. And this was all based, it wasn't just a lawyer saying, we're upset. They had an expert witness that told them, this is where they failed to meet the duty of care. Okay, so look at this timeline quickly here, that the elapsed time, I mentioned this earlier in the talk. So I put 10 years from the last involvement of the first consultant and only 3 years since the consultant number 3 between the time you were sued and after the event. Now, to be fair, I've got plenty of examples of earthquakes. I can think of an earthquake that happened up in the interior of Alaska. And I was working with a design engineer, not involved in this project, but someone like this. The first thing he did when he heard the news about an earthquake near his tailings dam design was call the owner. How'd we do? How'd it behave? What's going on? To me, that's the embodiment of what a professional should be doing. It shouldn't be waiting to hear if it's okay. It should be engaging with this process. In this case, because of this, well, even that 2007 failure time, the only one on site was that third consultant. The rest of us had been gone for 4 or 5 years, and we no longer had a day-to-day or even a frequent communication with this client. And so the impulse wasn't to engage and ask what went wrong, because the consulting firm number 1, the consulting firm number 2, all had been replaced by the work products of this third. So that thinking, I have to admit, looking back on it, I would have much rather seen one of us, 3 of us, go and engage early and avoid what happened next. So, yeah, 5 years, 10 years, 12 years can be a lifetime in the consulting business, and people do start new businesses and move on. And at least half of the overall defendants had moved on, individuals had moved on to other firms, or their firms had been merged with others. So it got messy from that perspective. Okay, after the statement of claim, you go into something called discovery. This is where everybody shares their evidence and their body of work, and in no particular order. I found I was looking at documents that have been scanned haphazardly that were out of order or even incomplete, and you had to spend time organizing this file. It includes the deposition process. It includes the expert witnesses being identified and brought on board. I should say the first thing that happens when you get that statement of claim, once you understand what it is, and I was at the front desk when I was served with that claim, that the first thing, that next 60 minutes for me was reading it, being hold of my internal counsel. We don't have a big legal department. And then the next notice is you notify your professional liability insurer. And that started this process where we now had to engage in, we had our lawyers, clearly the plaintiff had their lawyers, and this process starts. We argued a bit about where to argue. Then we moved into this discovery period, which was a major effort and a big time waster, and an awful lot of problems with how records were stored and shared. So much time could have been saved. We can talk about records retention near the end here. So discovery goes on. Settlement is possible at any time, of course, right? So you kind of look at your odds, you look at what you think your culpability is. You haven't seen the entire record yet. You haven't heard the entire argument. You haven't seen the expert witness testimony from the plaintiff. They're holding that until late in discovery. Once that's all done, you've got to decide, if I write a check, can I exit this process without, and just finish it, right? So it's possible at any time, but it's not enough that you're willing to offer a amount. Is the plaintiff prepared to accept it? So, and that little legal is more of a negotiation kind of strategy beyond the scope of this right now. I will tell you that the last settlement was 8 years after the statement of claim. So in fact, that last settlement happened after the plaintiff had presented their case in court. That's how far this process went before the last firm settled out. Okay, so here's a few of the hard lessons, the insights I want to share with you. 10 years doesn't seem that long, but records retention and the ability to sort of access what you relied upon, what data you used that you brought from others, and what data did you produce, what final interpretations or opinions did you render and issue to the client. Housekeeping is really the word I think of here. So it's not just about your final design package. All of us will have a binder or a directory saying final design or the AutoCAD tracking of drawing sets is not hard. But the digital communications, I mentioned the age of this case meant I think I had close to 100 banker boxes that were in my office, well, in the office as a whole, rotating into my office, just trying to pull through what was final draft and not confuse the record with draft or scratch paper or things that weren't part of the primary record. So, and I had faxes, that duplicated reports. That's okay, but that added to this volume, right? But today, so much what we're doing is tracking instructions and approvals all through emails. And so that migrating that record into your records when it comes to design or any professional services you're rendering is critical now. And I guess the other question for me is, you've seen there were external consultants on pit slope, 3 consultants involved in the heap leach, process people, mine planning people, everybody. If we keep our own records clean, what about the owner's retention policy? Isn't there an interesting nexus here where this work should all be kept and archived as some sort of knowledge base that the project owns, and that you don't count on all the individual pieces adding up to the total for the reasons, because of the overlap interfaces I talked about here? I don't have an answer for that, but I'll tell you, I do see some of the major mining clients, a client I'm working with now, we're in the process of a pretty intensive document control where it's mind-numbing a bit, but it is designed towards having a clear knowledge base of how decisions were made so they can always go back and look at it. It's the right plan. Second hard lesson to me was this missed opportunity for interdisciplinaries to share. The role we had was as a consultant on a part of the project. Other consultants and expertise was being run by the owner's team. And whoever's running, whether it's the feasibility study or the detailed engineering plan or construction, really has the only visibility of the whole project and making sure that parties are talking. Otherwise, they'll work on parallel paths and we won't cross. So what I show you right here is the pit slope design interacting with the mine planning. That's a convention. That's how things were running. Mine planner wanted to know how quickly you could develop, what sectors are weak, how does he develop what geometry does he use? And the mine planner tells the heap leach designers and the waste rock folks, here's how much waste I'm delivering to you at what rate. But the dialogue between the pit slope folks, remember how close they were, and the waste rock dump where this failure started? Didn't happen. Missed opportunity. Had there been a dialogue about why there was weaknesses in the pit, where there were weaknesses in the pit, and how that translated across that 500 meters, could have made a big difference. It was a missed opportunity. This is the new engineer of record definition. I took it right out of the Global Tailings Review Standard, which was just published in August of this year. I think you can read the entirety of it, but I've given you the gist of it. The engineer of record can delegate responsibility, but not accountability. So the buck stops with that independent engineer role. In this global standard, there's a bigger build about how you have the engineer of record interact with the tailings engineer. There's variations on this theme, but the EOR definition is this is where we're going. This is where we've been, and this is the best concise definition of what that looks like. So why is that applicable here? I use the word lines of accountability. So when you look at this graph I'm showing you now, it's the same 4 boxes. But the only engineer of record on this chart was the heap leach designer. The mine engineer designed the mine plan and did a great job. The mine plan delivered what it was supposed to do. The pit slope folks worked with the mine planner, did their job, but there was no stamped engineer of record for that. There's an understanding these are specialists that work together and they produce the outcome. Mine engineering as a PE is new in the state and it's emerging. I'm not minimizing that we can be lazy there. But when I'm talking about in terms of this failure, the engineer of record, the one that got sued, was the engineer of record for the heap leach facilities. And down there on the lower right-hand side, the waste rock was not designed, did not have an engineer of record. How many times, this is going back, you know, the vintage here, that in the past, That's just a place to put the rock. I don't need to line it, and if I put it in the right canyon or I buttress it the right way, I can pay attention to the acid rock drainage characteristics. And yet waste rock stability is an issue, and today that's not the way things work. But engineer of record roles for waste rock design are just as significant now as heap leach. But look at where we're going with the tailings design standard. You put in the metallurgical people who are also technical specialists, and now you have this definition I shared with you about the tailings EOR. So clearly we've got strong precedent, and I believe that the global tailings standard definitions and the protocols are strong, and they need to be that way. And this example I'm giving you from 20 years ago didn't have that strength, and we had the problem. But right now, the way things stand, those are the two EORs that can stand side by side. And where does this engineer of record responsibility, does it extend into waste rock work in global design standards or not? I'm not sure where that lands yet. We'll see where our industry goes. I think the last piece here is, as I was sitting with the expert witness and talking about, well, we didn't design the waste rock dump. We didn't, they did, or somebody else did. And the answer was, and we used this data and this interpretation of the geology from an external another party that knew the site. The owner gave us some of this information. Didn't matter. At the end of the day, that accountability, that definition is about, you can rely on data provided to you that you can check, but the opinions and decisions you make on that data are your own, and you own those. And even if someone takes your data and makes their own interpretations and move on down the road, that doesn't separate you completely from the project concept and liability. So this tenant of care is another way of looking at this. It doesn't matter if you're a geologist, engineer, process design person, it's global. This is where we're going. I think some of the other elements of this global standard, this idea of what's called an integrated knowledge base, that's what that owner's record retention policy is. How do you build an interdisciplinary summary of what was relied upon to produce whatever you built? And how do you preserve access to that? How do you update that and maintain it so you know it's behaving or that it's following the original design assumptions versus this fragmented work product that happened on this project? And I think using that database and having some continuity of at least that gives you a basis of continuity for making decisions going forward. And that's where robust design is headed. Tailings is there, heap leach is there. I'm just telling you, 20 years ago it wasn't. And look at us now. So that's my rumble in the jungle story and a few of the insights that came out of it. I'm happy for anybody to, I'll leave this up here for a bit here. Claire has my contact information. If you have some other questions beyond what we may talk about next year, I'm happy to take your, I'm happy to respond. So with that, Claire, thank you for the audience here. And we're happy to be here. Good stuff.
I have a question. I don't know if anybody else wants to chime in first, but so Terry, you mentioned during your kind of timeline, the only engineer on record was the engineer for the heap leach design. And you mentioned that that engineer left the second consultant, which is why they rebid for the third phase. My question is, did that engineer on record transfer to the consultant's company, which then won the bid for the third phase? So was it the same engineer of record for both consultants, or were there two individuals?
Two different individuals.
Two different individuals. And then did that second individual, was there a rubber stamping issue that also played into this, where rather than rechecking all of the drawings, they just said, they're PE2 and stamped?
No, that last engineer of record, I would put in the same class of the folks that have had success stories around the world.
Oh, okay.
And what happened here is, and this wasn't a big project, frankly, but it was a busy 2003. I forget what our goal. I know what copper was. You know, there was competition for resources, but you know what? They did a good job of vetting what was going on. There were a number of site visits by the third design firm, including the new engineer of record. The documentation trail was clean. In fact, they had a change even in their timeline from where they started to where they finished. So what am I talking about? 1, 2, 3, 4 different changes in individual engineer of record roles here, which that's a message to take out of this. Don't do it lightly. And owners don't swap and switch and think it can just be picked up and run with. This is what happens when we don't follow a more rigorous, robust design basis.
Okay. Thank you.
Thank you.
So this was settled out of court?
Yep. Everybody settled out. The order of settlement wasn't really proportional to liability. It kind of felt like the game that was being played here is the law firm for the plaintiff, kind of whoever had, if you have more paper in your file because you don't have it, because you kept everything, it's almost like that works against you because there's so many more things they could pick apart and look at. Well, you said this, or this draft, you were thinking this, but you didn't say it in the final. Yeah, so the order of settlement kind of came out of some folks who might have been very early in the conversation could have said, look, we didn't do anything after this. But 3 or 4 of the other firms in their various named subsidiaries kind of stayed in the game. There were times, Kadri, when I looked at where we were at, I'm like, this is silly. Why? This is such a time drain of my time. I see a few of my colleagues actually, one in particular that's on this Zoom call that knows exactly what we're talking about here. And we thought we were in great shape, and then we were not in great shape. And it wasn't because if you really looked at, Kadri, if you looked at the rock mechanics, you looked at, oh, it was obvious here. And where was the failure? Well, there was a failure to connect the dots between the two. You were kept in this area over here, and this guy was over here. That's where the real responsibility falls. But we never got to that.
Looks like somebody has chimed in over the chat.
Oh, I forget what that is.
Great talk. Thank you.
Thank you, Kadri. How can we emphasize and advocate for the need for better records? Can we quantify the cost of failure in the record somehow? Boy, that's certainly what the goal is. I encourage you to have a look. If you haven't looked at that full body of work in the Global Tailings Review Standard, I encourage you to do so. That knowledge-based discussion, to me, it's not a new idea, but they've really kind of created, I think, an efficient definition of why it's valuable. Now, a tailings facility has a kind of more so than a heap leach facility, has that change over its operating life. It gets bigger, and you change it, you leach it, you drain it, you may make it bigger. Tailings get bigger all the time, so that knowledge base has more of an emphasis in tailings, perhaps. But you're right, it's as much the knowledge base as it is that owner's retention policy as a whole, right? How do we take all the work that went into this feasibility study into the detailed engineering, and how do I host it in a way that is still accessible going forward? And you're right, unfortunately, there's enough small failures like this one, big in terms of the scope of this junior mining company. And certainly we all know about the big issues that have happened, the tragedies that have happened to the large tailings facilities. I think there's enough of that momentum now that we're going to be moving in that. You don't have to justify that knowledge-based discussion now. It's just how it works practically is probably the last part that needs to be solved because all the pieces are there.
So maybe that kind of goes into a question that I was wondering about. I mean, theoretically, technically, it wouldn't be too hard to actually come up with a secure online platform where you would just put everything in, like all your communications, all your phone calls, all your emails, all your designs. Basically, it all runs in a safe cloud blockchain, whatever solution that nobody can break, and everything just goes through there and everyone can access it. And if you transfer a project, the new owner gets full access. But then you also mentioned that in the end, that might be not even wanted by someone because it creates potential other liabilities, more details to dig into, and makes people responsible for stuff discoverable. Is there something out there? Is there people discussing something like that? Is that in the consulting space in general?
Yeah, there's definitely forensic type software applications out there that track all documentation. I'm just entering that world with a client that has a big legacy asset base that there's people who worked on it and did the work or built and have since retired or they're long gone. So they've got a desire to build this knowledge base and they're moving into, I think Equus happens to be the software package they're talking about for all their environmental data, all their historical data. I may have misspoken. I didn't want to give the impression that we want to hide data that was used to make decisions. If I give you any wrong impressions about discovery is that how inefficient it was because we did not have an organized file. And even if it wasn't organized, that one consultant would have, well, I had this copy from another consultant and this copy, and then the consultant who wrote that had their version plus a couple of draft copies. So just cleaning that up and having the one milestone review, I think everyone would benefit from that discussion. When things go very well, if there's questions about why they didn't go well, everyone benefits from having a transparent and organized log of of the body of work. And you're right, the cloud, the blockchain, these other technologies that are out here, I know the technology is there. It's just, and I know the workflow that makes sense. It's just having the paradigm shift is to making that workflow take effect for the building of the product development timeline, the construction phase, and the operation phase. So we know how to do it. I think the concerted effort to deliver on it, we're just in that moment, and we're in that phase now. Fantastic.
Great. Thanks, Doug.
Thank you. Happy to follow up if you have other questions on that. Thanks for everybody dialing in here. A lot of people I know got to say hi at the beginning.
Thank you,
Thanks for
Terry.
joining us.
And please join us next week for our seminar on October 28th. Mr. Levi Rawlings will be speaking on the data behind blasting. So that'll be an interesting one as well.
Fantastic.
Thank you so much, Terry. This was wonderful.
Thanks, guys.
Thanks, Terry.
Hey, Hugh. Nice to see you too.
Thank you, Terry.
Thank you all.